Okay, once again, welcome you all, and this is a part B of a Codeforces round 1073 Division 2. And in this contest, I always, I already tell you, I solve three problems, and this is the second part where I solve problem MEX reordering. Okay, and here we see what question says. Okay, you can also pause the screen and read the question. After reading the question, I'll tell you that what a test cases says and notes. Okay, after reading the note, you have a clear a clarification of the problem. See, you are given an integer array, okay, consisting of n elements. Denote this. Okay, this statements, I know, not in the waggish manner. I tell you that this problem is delegated to other parts of things, like you can't understand that what this statement says in the one side. See, in the other words, for the average split, MEX of the prefix must be different from MEX of the suffix. So what is the MEX? MEX is the minimum included number, okay, in the set. Let's suppose we have a 0, 1, 2. So in this 0, 1, 2, what we have, any MEX? Yes, MEX is always present, because if there is a no elements is present in the element, like 1, 2, 3, so we have a MEX equals to 0. Always MEX is always present in the array. We are sorry, I also have a note for you. Key observation of the problem. See, what makes two MEX value equal? First of all, we understand that what is MEX. Okay, then after we jump out to the code, and whether 0 is present, whether 1 is present, and whether 2 is present. See, there is a input. Okay, three test cases: 2, 1, 0, 3, 0, 3, 0, and 6, and these are the arrays. Okay, after see this, we need to print yes, comma no. Okay, and you can also check out the note section, which helps you to determine that what code says. And okay, so let's see the what problem says. Okay, a short note for you guys. Why this is hard? You must satisfy the condition for the every possible split. Like you are allowed to reorder the array freely, and there is a global structure that makes MEX unavoidable. Okay, if yes, then comment in the comment section and see what is the main idea behind this. The entire problem boils down to the frequency of the number 0. See, if segment does not contain 0, MEX equals to 0, and if segment contains 0 but not 1, its MEX equals to 1. So 0 is the most important number for controlling MEX. Case analysis is this: appears exactly once, says always yes, and it put the single 0 somewhere in the array, and one side contains 0, so MEX is always greater than 1, and other side does not, so MEX equals to 0. And if we talk about the case 2, case 2 equals to 0. 0 appears 0 time, which is already talk about in the test case 2. See, in the test case 2 we have a 0, 3, 0, so there is a 2, 0 in the array. And after saying this, sorry, okay, so 0 appears 2 or more than 2 times. This is the basically a third case. We already discussed about the base case in the question, and what the third case tells us. See, any segment containing at least 1 0 has the MEX equals to 1. So prefix contains 0 as well as suffix also contains 0. That's why we can say the both side get MEX 1. Okay, but it is impossible to avoid a equal MEX. Why? If we talk about case 4, 0 appears 2 times or more than 2 times and 1 exists, then we can say yes, this is the correct solution. Why? The reason is this: you can reorder the array so that the zeros are grouped carefully, as well as the presence absence of a 1 differ across splits. That's valid ordering exists in the third test case. See, here is a 6, and this is the array 105061. They are the 2 0 as well as 1 element. Okay, and we write yes here. And if we talk about the code, so I'll tell you my code and my approach behind this. See, okay, so this is the code. After taking input, I already declare the two variable named C0 and C1, and applying the for loop for this up to the n. Basically n is the first test case. Okay, let's suppose there are the 3 test case, then we print n. Okay, up to n. we declare the another variable name xy, and if our xy is equals to 0, this is reorder in the element. It is basically traversal in the array. We checking each elements. If our element is equals to 0, we need to plus plus the c0 condition. C0 is already a 0 as we defined earlier in the code, and if xy equals to 1 means if in the array there is an element which is 1, we need to print c1 plus plus, because we need to just adding the c1 1 so that we can perform a good operation in this. And this is the base case for this question. If our c0 equals to 0 0, if there is a nothing c0, okay, then we need to print no. If our, so listen carefully what I tell, okay. If our c0 is greater than 1 means we have a more than 0 elements in the array, more than 1, and c1 equals to 0 means there is only one element which is named as 1. C out no, okay, for this also. Else C out yes means you have also c1 which is greater than 0. Let's suppose you have more 1 value and more 0 values, okay. And this is the predefined test cases where this is used for the passing test cases in the good manner, also for the speed kind of way. And after watching CTT and apply my name condition, this is the function calling, and I already make a name, my name functions for performing the code, so that the nothing, so that how many people are submitting the code with the function name solve. I already was this, that's why I write my name instead of solve. And yes, that's it. While t minus minus, I just print my name, which is named as a function, and here I doing a function calling, and the last statement is written 0, as you know. And this is the basic approach, and here I already tell you about this. If you have any doubt regarding this, you can ask in the comment section. And yes, that's it. Okay, so meet you in the next video. Bye.